All right, so welcome to our Period 1 class. It has been a minute since we've done a recording here, but we've had some issues with the board. Hopefully, it'll go smoothly and there'll be no issues. So today, we have two objectives that we're going to accomplish. We're going to find the domain of a function defined by an equation, as well as graph piecewise functions. You guys remember those piecewise functions? No one remembers those? Oh, they'll come back to you. It'll be good times. All right, so let's start with looking at the domain of a function. In example 1, in the first part, I'm asking you to find the domain of a function when I've listed the points of this function. So who could give us the domain values for this function? Who knows the domain values? Yes, Tyree? So I heard 2 through 6. Now, do you know what I'm going to put? That's correct. Do you know what I'm going to put at the beginning and at the end to close it? Not brackets. The squiggly things, those are called braces. Yes, it's one of those words in English that means multiple things.
What is that called? Like a pair?
There's a word for it, I'm sure, but I don't teach English, so who cares? All right, let's go to example 2. Well, homonyms, what are homonyms? Things that sound the same but mean different things?
Pair.
Like there and there?
Oh, yeah.
Like pair and pair? Those are good. She said 2 too. That's funny. We just... Okay! So, I think it's kind of one of those. It's not a homonym, but something else. All right. What about when I give you a function? Ooh, do you know this one? Well, let's see. Do you know how to sketch this graph? What would this look like? What?
So it's a parabola.
It's a parabola because it's a quadratic function. And do you know what this minus 1 is going to do to it? Bring it down just 1 unit. So it's going to look like this. Again, just a sketch. Okay, so there's the sketch in purple of the parabola of the function. So now think about the domain. What x values are happening with this function? What x values are happening that you could plug in this function? No, just what x values work for this function?
1, 1.
Positive, negative, what?
Integer.
Integers? So I couldn't plug in something that's not an integer, like 2.6?
Number. X and Y.
Where am I going with this, guys? If she said positive and negative numbers, and I said you can also do more than just integers, guys, any number works. All real numbers. Any number, right? Any real number. So there's many ways to write this down. This is the way that I prefer to write it. I'm going to write negative infinity, comma, positive infinity. Do you know what symbols I'm going to use to open and close it? Not brackets. Because if you remember from a couple years ago, infinity always gets parentheses. Always gets parentheses. That's called interval notation. Write that down. Interval notation. When you use brackets and parentheses. This one up here is called roster notation. Just listing who is on the roster. All right. Roster notation is when you use those braces. Okay, what about for example 3? The same idea, but I've given you a different function. What is this function going to look like? Squiggle up and down? No.
1, 1.
0 what? If I plugged in 0, what do I get? What's 0 minus 7? Negative 7. Can I take the square root of a negative 7?
No.
I can't, so 0 is not going to be a part of our domain. What's the first number you can plug in that would be okay? 1 wouldn't work either. Not 2. 2 minus 7 is negative 5. 7! I'm sorry, Dina. I didn't hear you. I just heard all the other numbers. 7 minus 7
0.
is 0. And can you do the square root of 0? Yes, you get 0. So what's happening here is this is moving 7 units to the right. What? I see subtraction. 7 units to the right. We'll talk about that later. 7 units to the right on x.
Negatives would go left.
All right, so Chris's brain sees, wait, it's subtraction negative. Why is it not going left? When it's inside something like parentheses, a square root, you have to think opposite.
So when it says square root, all the sides are opposites.
It's not actually just about the square root. It's about where it is. It's inside your function. It's inside. I would have moved over here to the left 7 units. Now, why did this one move down? Because it's outside. If it would have been in the parentheses with the thing being squared, then it would have moved left or right. All right, we'll talk more about that later, I promise. Don't worry. Not today, but later on. Bless you. Student, what are they called? The tiles? You mean the quadrants? Quadrants, that's what they're called. They're called quadrants. Yes, 1, 2, 3, 4. I'm not sure why that's necessary right now.
Because I'm writing down that inside negatives on the square root makes it on the opposite side.
But technically this didn't go into a one. It's on an axis. Okay. So what's my first x value that I could use?
0.
7. Thank you. Was I able to use 7? Is it a closed circle? Yes. So I'm going to close it with a bracket. Comma. Where is this graph going?
0.
Infinity. Going on forever. So I'm going to put infinity and give it a parenthesis. Interval notation.
What type of interval notation? Wait, you can use brackets?
For interval notation, you use parentheses and brackets. For roster notation, you use braces. Just list them. All right, shall we do another example? Yes. Yeah.
They asked about the domain, but when it refers to y, like the y.
That would be called what?
Range.
The range is y. So if I asked to find the range of this one, it would be 0 to infinity. So this is going up forever. This one would be -1 to infinity, if it was the range.
And then the first one would be 10.
Correct, yes. But since you repeat a y, you can just write 110. It'd be 10, 20, 30, 40. You don't have to repeat. All right? Good question. Now, let's look at example 4. Here's your ranges coming in now, domain and range. So your brain was ready. What is my lowest x value that I could use for the domain? I don't think -4 is the lowest one. The lowest x value is not -4. It's all good.
-3.
And it's actually not -3 because you notice -3 has an open circle. So it's actually -2 point. Really? Forever. All right. So that's why we write -3, but because it's not included, we put a parenthesis. That's an open parenthesis. We're saying you go to -3, but you don't touch it. It's not included. Comma, what's the highest x value we have? 1, right? 1, and is 1 included? Yes, it's a closed circle. So I put comma 1, and I close it. Pablo, question?
Yeah. So the main is x and the range is y.
Correct, yes.
Hey, where did you get 1 from?
The x value is 1 for this point.
Oh.
Now let's do the range. What's the lowest y value?
-4.
Is it included?
Yes.
Yes, right? It touches both of those, -4. So we're going to put a bracket. What's the highest y value? 0?
Oh.
What should I do there?
The
So, because most people put parentheses, but guys, what about this? Does that touch 0?
Yes.
Sure does. So they tricked you. They tried to trick you. Most students would see this open circle at 0 and put a parenthesis. But notice this part of it, does it touch 0? Yes, it does. So it's included. All right? Close always trumps open. Yeah. Included.
And then,
Parenthesis, not included. That's called interval notation. All right, you guys ready to try on your own?
no.
No? Okay.
Not yet.
Let me know when you're ready.
Go.